Hi guys, what's up? Welcome to Weekenders Club. I am Poval. This is the third video in the Terraform tutorial series. In the last video, we learned what is Terraform, how to install it, what is HCL language, the basic syntax of it. In this video, we will talk about creating, updating and deleting the infrastructure, how to use all the important Terraform commands and what do they mean. We will delve deeper into providers, what are the different kinds of providers, and how we can work with multiple providers in a single configuration file. And also the naming convention. भी आपको सुन के ये too much लग रहा होगा, but please watch the video till the end और आपको लगेगा कि वाओ उन्होंने कितने simply समझा दिया. So, let's get started, shall we?
Earlier I mentioned that Terraform supports over 100 providers, including the local provider that we have used in the previous example. Other common examples are AWS to deploy resources in Amazon AWS Cloud, Azure, GCP, Ali Cloud, etc. Each of these providers have a unique list of resources that can be created on that specific platform, and each resource can have a number of required or optional arguments that are needed to create that resource, and we can create as many resources of each type as needed. It is impossible to remember all of these options, and of course we don't have to do that. Terraform documentation is extremely comprehensive and it is the single source of truth that we need to follow. If we look up the local provider within the documentation, we can see that it only has one type of resource called the local file. Under the argument section, we can see that there are several arguments that the resource type block accepts, out of which only one is mandatory, the file name, and the rest of the arguments are optional. Now we will learn how to update and destroy infrastructure using Terraform. In the previous video, we saw how to create a local file. Now let us see how we can update and destroy this resource using Terraform. First, let us try to update this resource. Let's add a file permission argument to update the permission of the file to 0700 instead of the default value of 0777. This will remove any permission for everyone else except the owner of the file. Now if we run Terraform plan, we will see an output like this. From the output we can see that the resource will be replaced. The minus symbol in the beginning of the resource name in the plan implies that it will be deleted and then recreated. The line with the command that reads forces replacement is responsible for the deletion and recreation. And in this example, that is caused by the file permission argument that we added to the configuration file. Even though the change was trivial, Terraform will delete the old file and then create a new file with the updated permissions. This type of infrastructure is called an immutable infrastructure. We saw this briefly when we discussed the different types of IAC tools. If you want to go ahead with the change, use the Terraform apply command and then type yes when prompted. Upon confirmation, this existing file is deleted and recreated with the new permissions. To delete the infrastructure completely, run the Terraform destroy command. This command shows the execution plan as well, and you can see resource and all of its arguments have a minus symbol next to them. This indicates that the resource will be destroyed. To go ahead with the destroy, confirm yes, and this will delete all the resources in the current configuration directory. In this example, it deletes the file root pets.txt. Now let's take a look at providers in more detail. We saw in the previous section that after we write a Terraform configuration file, the first thing to do is to initialize the directory with the Terraform init command. When we run Terraform init within a directory containing Terraform configuration files, Terraform downloads and installs plugins for the providers used within the configuration. These can be plugins for cloud providers such as AWS, GCP, Azure, or something as simple as the local provider that we used to create a local file type resource. Terraform uses a plugin-based architecture to work with hundreds of such infrastructure platforms. The providers are distributed by HashiCorp and are publicly available in the Terraform registry at the URL registry.terraform.io. These are the three tiers of providers. The first one is the official provider. These are owned and maintained by HashiCorp and include the major cloud providers such as AWS, Azure, GCP, etc. The local provider that we have used so far is also an official provider. The second type of provider is a verified provider. A verified provider is owned and maintained by a third-party technology company that has gone through a partner provider process with HashiCorp. Some of the examples are the big IP provider from F5 Networks, Heroku, DigitalOcean, etc. And finally, we have the community providers that are published and maintained by individual contributors of the HashiCorp community. Terraform init command when run shows the version of the plugin that is being installed. In this case, we can see that the plugin name HashiCorp/local with the version 2.0.0 has been installed in the directory. The Terraform init is a safe command and it can be run as many times as needed without impacting the actual infrastructure that is deployed. The plugins are downloaded into a hidden directory called .terraform/plugins in the working directory containing the Terraform files. In our example, the working directory is /root/terraform local file, and the plugin name that you see here, HashiCorp/local, is also known as the source address. This is an identifier that is used by Terraform to locate and download the plugin from the registry. Let us take a closer look at the format of the name. The first part of the name, which is in this case is HashiCorp, is the organizational namespace. This is followed by the type, which is the name of the provider such as local. Other examples of providers are AWS, Azure, Google, etc. The plugin name can also optionally have a host name in front. The host name is the name of the registry where the plugin is located. If omitted, it defaults to registry.terraform.io, which is HashiCorp's public registry. Given the fact that the local provider is stored in the public Terraform registry within the HashiCorp namespace, the source address for it can be represented as registry.terraform.io HashiCorp local or simply HashiCorp local by omitting the host name. By default, Terraform installs the latest version of the provider. Provider plugins, especially the official ones, are constantly updated with the newer versions. This is done to bring in the new functionality or to add in the bug fixes. And these can introduce breaking changes to your code. We can lock down our configuration files to make use of a specific provider version as well. We will see how to do that later in this tutorial. Now, let's take a look at the configuration directory and the file naming conventions used in Terraform. So far, we have been working with a single configuration file called local.tf. And this is within the directory called terraform-local-file, which is our configuration directory. This directory is not limited to one configuration file. We can create another configuration file like this. The cat.tf is another configuration file that makes use of the same local_file resource. When applied, it will create a new file called cat.txt. Terraform will consider any file with the tf extension within the configuration directory. Another common practice is to have one single configuration file that contains all the resource blocks required to provision the infrastructure. A single configuration file can have as many number of configuration blocks that you need. A common naming convention used for such a configuration file is to call it the main.tf. There are other configuration files that can be created within that directory, such as the variables.tf, outputs.tf, providers.tf, etc. I will be talking more about these files in the later sections of this tutorial. Let's see how to use multiple providers and resources in Terraform. Until now, we have been making use of a single provider called local to deploy a local file in the system. Terraform also supports the use of multiple providers within the same configuration. To illustrate this, let's make use of another provider called random. This provider allows us to create random resources such as a random ID, random integer, random password, etc. Let us see how to use this provider and create a resource called random pet. This resource type will generate a random pet when applied. By making use of the documentation, we can add a resource block to the existing main.tf file like this. Here we are making use of the resource type called random pet. In the earlier section, we saw that the resource type can be broken down to two parts. The keyword before the underscore is the provider, which in this case is random. And the keyword following it is the resource type, which in this case is pet. Let's call this resource myPet. Within this resource block, we will use three arguments. First one is the prefix that is to be added to the pet name. The second argument is the separator between the prefix and the pet name that is generated. And the final argument is the length, which is the length of the pet name to be generated in words. Our main.tf file now has resource definition for two different providers. One resource of the local file type that we already created earlier and another resource of type random pet. Before we create an execution plan and create these resources, we have to run the Terraform init command again. Now, this is a mandatory step as the plugin for the random provider should be initialized in the configuration directory before we can make use of it. In the command output of the Terraform init, we can see that the local provider was previously installed and it will be reused. The plugin for the random provider, on the other hand, will be installed as it was not used before. We can now run the Terraform plan to review the execution plan. As expected, the local file resource called pet will not be updated as it is unchanged from the previous apply. A new resource by the name of myPet will be created based on the new resource block that we just added. Now, let's apply the configuration using Terraform apply. As expected, the local file resource is left as it is. But now a new resource has been created which is called myPet. Random provider is a logical provider and it displays the results of the pet name on the screen like this. Here an attribute called ID which contains the name of the pet is written by the apply command. Before we move on, please note that in my illustration the dog icon stands for a pet and I will be making use of it throughout my videos. The random pet can generate any pet name and it does not have to be specifically a dog.
So that was it for this video, guys. अगर आपने यहाँ तक देखा है तो thank you so much for watching. Please like, share, comment and subscribe to my channel. Next video में I'll tell you about variables and resource dependencies. So please wait for the video to come up. Until then, have a nice day. Bye.